Metal. It's complicated. This piece of aluminum foil is so thin and light, I can't even measure it. It's so weak, a gentle breeze can easily bend it. But it's strong enough to lift 10,000 times its own weight. That dichotomy is not a fault. It's a feature. A very handy feature. Most metals can be purposely bent to prevent them from bending. Accurately bending metal is one of the most efficient ways to make strong, lightweight structures, but that doesn't mean it's easy. The bending part is pretty straightforward. The thicker the metal, the harder it is to bend. If you also want accuracy, things get a lot more difficult. Luckily, there's a machine whose sole purpose is to accurately bend metal. It's called a press brake, and I just bought one. I know what you're thinking. It's bigger than it looks. Actually, you're probably thinking, don't you already have a press brake? Technically, I have two. Does it bother anyone else that the logo isn't centered? My current press brake is mechanical. It's got a big scary flywheel and a crankshaft. You engage the clutch and ka-chunk, ka-chunk. It works, but it's not very handy. It has a fixed stroke, so every new setup is basically a guess. There's little notes and reminders and numbers written all over the machine. It also predates the whole concept of safety, so your digits are your problem. These things have been almost entirely replaced by hydraulic presses. They're safer, faster, and a lot more accurate. The accuracy of the mechanical brake mostly comes from the dies. If you crash them together hard enough, you get a pretty repeatable bend. The problem is you really need a special set of dies for every thickness and angle you want to bend. With a hydraulic brake, you really just need 3 points of contact, and you can bend any angle in any material, with fewer dies and a lot less force. I've been accumulating parts to convert my mechanical press to hydraulic, but it's not so simple. You might have noticed there's an obvious problem. It's basically impossible to balance or synchronize two hydraulic cylinders, especially when they're so far apart. A lot of clever people have tried to solve this problem. Crazy mechanisms are a common choice. I believe this is called a herringbone linkage. Others try to do it hydraulically. This is a flow divider. It's basically two gear pumps connected together. In theory, the amount of oil passing through both gear sections should always be the same. This is a fun one. The oil gets pumped into one cylinder. The opposite end of that cylinder feeds the other cylinder. It's called rephasing. The most common solution is a big torsion bar. It mechanically links both ends of the ram, just like a sway bar on a car. The Europeans had a different idea. They literally flipped the press on its head. They also moved the cylinders to the middle and added extra guides at the top, which is now the bottom. That keeps the ram square, everything balanced, and it solves another annoying problem. The beams of the press will actually deform slightly and cause an uneven bend. With this design, both beams deform in the same direction and basically cancel each other out. Both designs work, and both are still being made, but they have the same limitation. You can really only bend in the center of the machine. The force has to be centered. The Holy Grail press brake would combine the best features of both designs, but have independent control of each cylinder. Attempts were made to do this mechanically. They use a cable and some pulleys to connect the ram to a hydraulic valve. If the ram tilts, the valve shifts and sends more oil to the slower cylinder. I'm sure you can imagine how well that worked. There's really only one way. Computers. Is there anything they can't do? All we need is a solenoid valve and a position sensor for each cylinder. No matter how you load it, the computer can synchronize both cylinders within a few microns. That's how the new machine works. If it works. If we ever get it. It actually doesn't stop there. The new thing is to get rid of the hydraulics for obvious reasons. They replaced the hydraulic cylinders with huge ball screws, or the coolest one I've seen uses flat belts. It's basically a giant block and tackle. Each pulley doubles the force, and because it's evenly spread across the beam, there's basically no deflection. I'm sure that's way more than you ever wanted to know about obscure industrial metal bending machines. Unfortunately, I don't have the new machine. We're currently experiencing a higher than normal volume of winter. It's also a month before Christmas. Santa's a little busy. This is a Gasparini 4-axis CNC press brake. As far as press brakes go, this is a pretty small machine. It's 25 years old, it's Italian, and it's entirely computer controlled. Hard to see how that could possibly go wrong, especially when it bears the mark of the beast. That means the seller doesn't check, test, or guarantee anything. It's a gamble. The stuff is really cheap, but you get what you get, and you don't throw a fit. I think it looks pretty good. It is leaking quite a bit of hydraulic oil, but that puts it in a pretty large group. I guess let's power it up and see what happens. It's currently set up for high voltage, which I don't have. We need to switch it over to low voltage. That's not a press brake. The machine came with a box of manuals for a Hyundai machining center, which is not very helpful. But to my great relief, the correct manuals were inside the cabinet. Fixing this machine without hydraulic and electrical schematics would be somewhere between very difficult and completely impossible. The main motor that drives the hydraulic pump needs to be retapped. There's also 2 transformers that need to be retapped. When you have the voltage, you double the current, so we need to adjust a few breakers. I should mention this is only possible because this machine is rated for dual voltage, which means all the breakers, wires, contactors, connections, they're all designed to handle the higher current, which is really nice because a lot of these machines are high voltage only. There are 3 key switches, one's missing, one has a missing key, and one has a broken key. I can bypass the missing key. I tried twice to replicate the broken key. After a bit of filing, I was able to get it to work, but this switch is pretty crunchy. Well, that's a good sign. Real good sign. Nothing like that. Yeah, it tripped everything. Tripped all 3 breakers. Okay. I think we might have a problem. It's not going to work like that. You can't have a dead short between 2 phases. Actually, between all 3 phases. Let me try that again. Looks a little better. That sounds pretty good. The control powers up, which is good, but I can't get past this start machine warning, and it won't reset the emergency stop. Apparently that means it's not getting a signal that the pump is running. The problem was right in front of my face. I forgot to reconnect this little auxiliary contact after I load tested the circuit breakers. Now the control starts and the back gauge homes out, but I can't get the ram to move. The pump was spinning the wrong direction, so I had to switch 2 wires to reverse the motor, but the ram still won't move. I'm kind of stuck. There's got to be something I'm missing. If I'm reading the schematic right, here's how I think it works. It's pretty clever. I never understood how these machines could be so strong and so fast. Normally you get one or the other. The secret is in the cylinders. They have these huge rods. It's not for strength, it's to reduce the volume on the bottom side. The pump constantly circulates oil back to the tank. That's the only part that's currently working. To move the ram, the safety valve blocks the pump, causing it to build pressure, and it unblocks the bottom of the cylinder. The ram comes down really fast. It's not being pushed. The pump really isn't doing anything. It's essentially falling under its own weight as the oil is released from the bottom of the cylinder. It stops just before the bend, blocks the bottom of the cylinder, and now the pump starts pushing. It pauses at the bottom, then the pre-fill valve is pushed open and oil is pumped into the bottom of the cylinder. The volume at the bottom is very small compared to the top, so it moves up really fast, and that big pre-fill valve lets the oil out at the top of the cylinder right back into the tank. It's very clever. It's also very complicated. It gets even worse when you add the other side. Just for reference, these 2 proportional valves cost about what I paid for this whole machine. So it just doesn't make sense to build something like this myself. There's also a safety barrier. It works like the sensors on a garage door. It stops the machine if any squishy human appendages block the light beam. I tried disabling it, but the ram still won't move. I did ask for help, but eventually I stumbled onto the solution. There's a pedal. The ram will not home unless you push it. I guess that's just tribal knowledge that they don't bother to put in the manual. I have no idea what I'm doing, which should be pretty obvious at this point, but it goes up and down. That's pretty cool. I made some minor adjustments to level the ram. It seems to be very repeatable, and I think it's working as it should. Unfortunately, we still can't actually use the machine. Press brake dies mostly fall into 2 similar but incompatible standards: European style, which this machine takes, and American style. Can you guess which kind I have? There's a few other problems. Some of these clamps are not even close to flat. Someone welded up the adjustment wedges. Don't ask me why. I broke one loose, but you can't adjust them to be flat. They're either worn or bent or both. The hydraulic pump leaks all the time, but it leaks a lot more when it's running. I thought it would be the shaft seal, but that would be too easy. It looks like it's leaking between the sections of the pump. Probably some kind of O-ring. Also, this coupling should have a rubber insert. It's called a spider. It's been gone for a long time. The aluminum jaws have been eating into each other. I actually 3D printed a spider out of TPU. It came out perfect, but I decided not to use it. This coupling is completely slapped out. That's how it's supposed to fit. The pump side is pretty easy, using this adorable little taper lock bushing. The motor side is a bit more difficult. I couldn't find a coupling with a keyway. It probably doesn't need one, but I'd like to have it. I don't have the correct broach. This is a 38mm bore, but I do have an 1.5 inch, and if you force it, it'll fit. Of course, now we have a 3/8 keyway instead of a 10mm. So I ground a tool from an old tap and did some manual broaching on the mill. It's soft aluminum, so it really didn't take very long. Not sure what I'm supposed to do here. Need a 22mm gap between both halves of the coupling, but I can't really measure it or even see it once it's assembled. I'm thinking I'm going to shove it together without the spider, and then that'll set the depth, and then I'll just move it back 1mm. Should be close enough. And it's backwards. There we go. This is still wrong. That one's wrong too. Should be normally open instead of normally closed. I swear, there's a hole in my brain shaped like an electrical connector because I can't get it right. If I would have just hooked up wires at random, I would have had a better chance. The pump. It's a Bosch Rexroth. They sell a seal kit. Supposedly there are 2 in stock, but after 2 distributors, 7 phone calls, 11 emails, 2 tax forms, over $400, and 24 calendar days, I still have no idea when or even if I will ever see one. Well, that's how you pack a pallet. The tooling I bought included some clamps. The paper shims don't inspire a lot of confidence, but they really don't look too bad. They cleaned up pretty good. I think there's enough parts to assemble 8 good clamps. They do require some modification. Need to add a safety groove. Actually, 2 safety grooves. Oh no. How did I not check that? I assumed all these clamps were the same. And this part is the same. But everything else is different. They're different heights, different thicknesses. There's no way I can use them. Wish I would have known that about 8 hours ago. I'm gonna go cry. There's also a problem on the bottom. These adapters should be exactly the same height. These things have more potholes than an Illinois road, but the dimensions are spot on. Yeah, there's your problem. Press straightening is very tedious. You chase the bend around, you overbend and have to bend back. The frustration builds until you're just about to chuck the part through the window. Then magically, it just falls into place.
Pretty close.
I also enjoy the circular irony of using a press to straighten parts that were unintentionally bent in a press while intentionally bending other parts. That's kind of fun. Dies are installed and adjusted. The back gauge fingers are adjusted. I think we're ready. Got it. It's fine. The length is just about perfect. It's a little overbent, but that's easy to correct. Unfortunately, there's another problem, and it's not easy to correct. The machine needs to know everything: dimensions, angle, material, thickness, length, the shape of the dies. Then it calculates how to move the machine, compensate for radii and springback, and make a perfect bend. If I try the exact same bend with the part shifted to the side, it stalls out. Move it to the middle, and everything works fine. It took me a long time to figure out what was going on, and I still don't know if it's actually a problem. The pressure regulator is computer controlled. The machine knows how much force the bend should require, and it limits the hydraulic pressure to 120% of the required pressure to make the bend. It must be some kind of safety thing to keep the machine from hurting itself. If we want to bend a part that takes 10 tons of force, the machine limits the pressure so we have 6 tons of force in each ram. If we move the part off center, we need 7 or 8 tons of force in one cylinder. We only have 6, so that's not going to work. I don't know what to do about that. Bending off center is kind of the whole point with a machine like this. For now, I'm just lying to the machine and telling it the parts are longer than they really are. That's not ideal, but it does work. Traditionally, the first job with a new machine should be something for the machine itself. Instead, I want to use my newest press to make something for my oldest press. This Greenard arbor press is actually the only machine I still have from my very first shop. I've moved it 6 times to 4 shops. It's in great condition and it's super handy. We used to run a production job with it. I bet it's installed 10,000 bearings. But the stand really sucks. Here's a good example of an off-center bend. The bottom of the stand is a 3-sided box. Instead of moving the dies around to center the part, I can just move the part.
That'll work. That'll work nicely.
Green.
That is white.
This is off-white.
That is not green.
Cream. Cream.
Oh, I think you said green.
No.
Cream.
Cream.
Yes.
Did you make the stand
Yes.
with your phenomenal welding skills?
Doesn't it seem like it's a lot more usable height now? It's like a hobbit-sized press.
Oh. I was like, probably not. Like, it was at a good height for me, so I don't know what you're talking about.
Well, I couldn't paint my way out of a wet paper bag, but, you know, from a distance, in the right light, seems pretty stable. It's got holes to bolt it down, which I'm definitely gonna maybe get around to someday. I know there are ways to eliminate these keyholes, but I'm still a newbie. I really like the shelf for all the blocks and custom tools. It's way better than stacking them around the press like Jenga tiles. That's it. It works. Mostly. And I still have 10 fingers. We definitely have some bugs to work out. The ram is kind of jerky and uneven when it goes up. I don't know why. I don't think it should do that. We're only using 7 clamps. The one that doesn't match also doesn't work. They must have pulled it out of the scrap bin. Speaking of the scrap bin, the dies I bought they're not great. The two on the bottom should be identical, but the far one has either been modified or it's completely worn out. That's kind of the story for the whole rack. I don't know, I'm calling it a win. This machine is pretty cool, and it could have been a lot worse. I'll tell you a story. I think we're past the statute of limitations. Before I was a weird guy on YouTube, I was a weird guy who traveled around fixing CNC machines. I went out to look at a big vertical lathe. It's just what it sounds like. It's a lathe turned 90 degrees. But this was a big boy. I think it would swing like 6 feet, 2 meters, and it weighed something like 40 tons. These guys bought it out of a General Electric factory for basically scrap price. But after all the rigging and trucking and permits, they had 6 figures wrapped up in it, and they had nowhere to put it, so it sat for over a year while they built onto the shop, poured a special foundation, put in all the electrical, the cranes, all that stuff. They moved the machine inside, powered it up, and it wouldn't do anything. I rolled in, I started poking around. It had a GE Mark something CNC control, and I remember it had 239,000 hours on it. It wasn't actually cutting that whole time, but they powered it up sometime in the mid-1980s and never shut it off. Every electrical component had been running continuously for 27 years. And amazingly, they were all working. I poked around a little more, didn't get very far. Just like my press brake, it wouldn't go through the homing procedure. Without homing, it doesn't know where it is, and it basically can't do anything. I figured it was some kind of, tribal knowledge deal. So I managed to get a hold of a maintenance guy at GE, and he knew everything about the machine. He told me to go to a special directory and look for some parameters or something, but I couldn't find them. Long story short, when GE bought the machines, they actually had 3 identical machines. They really wanted automatic tool changers, and that was not available. So they just designed and built their own. The control was also made by GE, so they called their buddies at the controls division and had them write some software to make the control work with the new tool changers. You see where this is going yet? When they sold the machines, some guy with a clipboard full of ITAR forms went through the control and deleted all the proprietary GE programs, including the programs for the tool changer. The tool changer is part of the homing procedure. 1 or 2 keystrokes turn those machines into 40-ton boat anchors. So I don't know how the story ended. There was nothing I could do. It's kind of the ultimate sunk cost fallacy. They could try to negotiate with GE to get the software if it still existed. As I recall, you had to have an external tape drive to load it. Who knows if that was still around. You might be able to put the machine back to the factory default settings if you could find them, and then just delete the tool changer. The only other option was to replace the CNC control, and that was going to cost in the neighborhood of $80,000. And that was 12 years ago. Who knows what it would cost today? It could be twice that. So, yeah, you win some, you lose some. I'm calling this a win. Thanks for watching. Look who finally showed up. $400. Oh well, at least we finally got him. It's gotta be the pump leaking.
Where did you find the tractor?
Max brought it to me.
Oh. Can I have it?
It's yours.
Oh, yeah.
There it is. The real internet. So close. Maybe next year.